So in projectile motion, we can assume that a particle is thrown in the space and which moves under the effect of gravity only. So this is the most important line, that in the space the particle moves under the effect of gravity only. Okay, so only one force is acting when this particle is in air. Okay, only one force is acting on it. Always remember this force, that is gravitational force. You know the formula of force is equals to m into a. So for here in this case, the force is the weight, m remains the mass, and a is acceleration due to gravity. So that's the weight of your body is actually the gravitational force acting on it, that is m into g. So only force acting. In the horizontal direction, fx is 0. So in space, in air, we have fx is equals to 0 and we have fy is equals to mg. So remember these two things. Okay. So if fx is 0, then fx is equals to m into ax, means along x-axis, and fy is definitely m into ay. Yes, you're asking something? Any questions?
No, sir.
So if fx is 0, then ax will also be 0. And ax acceleration in the x direction is 0, means Vx is constant. There will be no change in the horizontal velocity. Whereas in vertical motion, downward motion, we have acceleration, that is equals to acceleration due to gravity g. Is this clear, this concept? And see, very simple thing. We have the formula F is equals to ma. So we have, whenever we study particle moving in the air, then we are actually studying two motions. So whenever there is a projectile motion, we have two motions. So projectile motion equals to horizontal motion plus vertical motion. Important thing is that these motion do not depend on each other. They are not concerned with each other. Okay? There is no concern. They do not depend on each other. They are independent motion. A motion depends on the force acting on it, because that is Newton's first law. Newton's first law says that if you have net unbalanced force, then the state of the body will change. Means the body will accelerate. So here F net. So first law says that whenever there is F net, the state of the body will change. Newton's second law tells us what will be the acceleration. So this is the formula: net force is equals to mass into acceleration. So if there is net force, there is acceleration. If there is no net force, there is no acceleration. So these projectile motion has two independent motions, and motion depends on force. In case of horizontal motion means net force acting in the x direction. Vertical motion means net force acting in the y direction. So Fx is equals to m into ax, because mass is constant. Mass is a scalar quantity. So it has no component along x-axis and y-axis. So F and A are vectors. So they have their components along x-axis and they have their components along y-axis. Now along x-axis, Fx is equals to 0. So if Fx is 0, there is no force acting in the x direction. So then of course put 0 here. 0 is equal to m into ax. So m cannot be 0. So it means ax is 0. So if ax is 0, we have the formula v is equals to u plus at. So this formula will have vx is equals to ux into ax into t. T is again a scalar quantity, so no x and y. So if ax is 0, then it means vx is equals to ux. Means the final velocity is equal to initial velocity. Velocity will not change in the x direction. So constant velocity in x direction. Now what about here? Here the force acting in the x direction, we call it weight also. And the acceleration y direction is g. So weight is equals to mg. So g is the acceleration. Here the acceleration was 0. But here ay is equals to g. Now you know the acceleration. So you can use the, and this is a constant acceleration. And you know the formulas that you can use for the constant acceleration. V is equals to u plus at. S is equals to ut plus half at square. And v square minus u square is equals to 2as. So you can use these three formulas here. Here also you can use, but in these cases a is equals to 0. So this equation, a is equals to 0, v is equals to u. What about this equation? The next equation, what will this, the next equation will give you? So this equation number 2, what will this give you? This equation. So Sx is equals to ux into t, because this a is 0, ax is 0, so this term will be 0. So if you have constant velocity, then you simply multiply it with time, you will get the distance traveled in the x direction. Now here also a is 0, so v square is equals to u square, v is equals to ux. So basically you have only these two formulas here. Here you have these three formulas. Okay. Now we have like this diagram, you can see there is an angle between the velocity vector and acceleration during the flight. So that's the angle between g and u. In ascending motion, theta is obtuse. So in ascending motion, you will find that the theta is obtuse. And during the descending, this theta is acute. And at the top, this theta is 90 degree. During the flight, theta decreases continuously which increase with increase in time. Okay. Next concept. In projectile motion, magnitude as well as direction of velocity continuously changes. So there must be presence of tangential as well as radial component of acceleration. So acceleration will also have two component, tangential component and radial component. So what is the meaning of tangential component? What is the meaning of radial component? So object is moving in a parabola during a flight. Here also, if you throw the object from here, from some roof, then this is this part, this half part of this parabola. And if you take any particular part, small part, it is a curve, and you can draw a whole circle with that curve. Okay, so you can draw a whole circle. Suppose you are taking this part of the curve, so you can draw a whole circle with that curve. So now if we talk about the components, then this will be the radial acceleration. And where is your g? You have this acceleration which is vertically downwards, right? So this is vertically downwards, g. And this is the direction of u tangentially. Initially, when we have thrown it, we call it u. Otherwise, at any point of time, the velocity, we will tell it as v. So this is a tangent. And now this is g. And this angle is so this velocity, let the angle that it is making is theta. So this is the angle that velocity is making with the horizontal. So this is theta. So if this angle is theta, this angle will also be theta. कैसे हुआ ये? This is your tangent. This is your radius. So this angle is 90 degree. Okay. And this is again, now this is horizontal, and this angle theta. So this angle is 90 and this angle is also 90. So if you assume this is angle 1, 2, 3. So 1 plus 2 is 90 and 2 plus 3 is also 90. So if 1 plus 2 is 90 and 3 plus 2 is also 90. So comparing these two, you can tell that angle 3 is equals to angle 1. Okay. So in maths, we do this kind of thing at a lot of places. Okay. So this angle is theta, this angle will also be theta. So 1 and 3 will be equal and they are theta. Okay.
Okay, sir.
Now we are talking about this. This is theta. So let us talk about this. This is your g. You want to resolve this g into components. So this is your, actually you are going to resolve this g. So this is your diagonal. Okay. So and this will be your rectangle. So if you add 1 and 2, you will get the resultant g. Now you have to divide g in two components. So this angle is theta. So what will be this? This is your adjacent side. So open Adam, open, hurry, hurry, Adam. So sine cos tan. So adjacent side is hypotenuse cos theta. So hypotenuse is your g, the length is g. So this is g cos theta. And the opposite side is g sine theta. So this g sine theta, so this will also be g sine theta. So you have these two components, g cos theta and g sine theta. So this was your acceleration. Okay. So you have resolved this acceleration in two components. One is along the radius towards the center. So we call it radial acceleration. So AR is equals to g cos theta. And this is along the tangent. So we call it tangential acceleration. So AT is equals to g sine theta. That is how we resolve components. So these components are resolved. This is very important concept. So that this acceleration is resolved in two components. So very important thing is how to resolve these components, students. See, okay, this is the diagonal, but rectangle can be this way also, that way also. See, we resolve it. We resolve the component in the direction of motion. Okay, so what's the direction of motion here? So this was the hint. This is the tangential velocity. So this was the direction of motion. Actually, okay, tangential, this is the direction of velocity. So this is the direction of motion. And now opposite to it will be your AT. So you have got the AT. So 90 degree to it, you get AR. So that's how. So it's important we resolve the components of acceleration in the direction of motion. So here, this is the direction of motion, and 180 degree to it we have direction. That's the tangential acceleration, and this is the radial acceleration. So we have this concept written over here. So this is but at this point the tangential component becomes 0. Okay, so at the top tangential component becomes 0 and AR is equals to G, right? Otherwise at rest of the place AR is equals to G cos theta and tangential is, so like here tangential component is G sine theta and radial component, this is a radial component, that is, so assuming this has arc and complete the circle, so this towards the radius, so radial component. So very important concept. So in ascending motion AT is against V, so V is in this direction, AT in this direction. But when you, so A decreases because acceleration, and so this tangential acceleration, and so tangential acceleration in this direction means force is there in this direction. So if force is there in this direction and you are moving in this direction, so obviously your speed will decrease. But here velocity is in this direction and tangential acceleration is also in this direction, force is also, so this speed will increase. So here the speed decreases and speed becomes 0 here, and here the speed increases because here this here the angle was 180 degree between u and tangential acceleration. Here the angle between them is 0 between the tangential acceleration and velocity, direction of velocity. So in decreasing motion AT is in the direction of V, so V increases. So very important basic concepts. Now since deceleration in y component of velocity in ascending motion is equal to acceleration of y component of velocity during descending motion, so the time of ascending motion is equals to the time of the descending motion. And so two important things, time ascending is equals to time descent. And second thing, the magnitude of y component of velocity at the same height in ascending will be the the y component velocity at the same height in ascending as well as descending motion is the same, but it's in opposite direction. So that's the second point. So this is the first point, that time ascent is equals to time descent, and second point is about the magnitude of velocity. Now at maximum height, Vy is equals to 0 and Ux is equals to Vx is equals to Ux, that is U cos theta. Okay. So at maximum height, what will the velocity? So y component is 0, you are left with only x component, and x component is your U cos theta. So y is 0, so Vx square V. So you get this as, so Vx and the velocity at maximum height remains the same because Vy is 0. Now when the particle again return to ground at the point B, its y coordinate is 0 and its magnitude of velocity is u, and at an angle theta with the ground. So how much the angular change? So here you have thrown it, the projectile, with an angle theta, and here it is coming down and it is making an angle here theta with a horizontal. So here the initial velocity was u, here also the final velocity will also be u, means v will be equals to u, and thus this is the same angle here. So that's the symmetry. Now how much is this angle rotated? So so the angular change, or the difference between the initial velocity and final velocity, is actually 2 theta. So you move it in this direction, that theta, and then move it in this direction further theta. So you will have 2 theta. See, this theta and this is same, right? These two lines are parallel. So the total change here is the angular change, or you can say the difference between the initial and the final velocity, because magnitude remains the same. So in terms of angle, the difference is 2 theta. Now if we move further, some other like properties of projectile motion. Let us see. Some other properties. Very important concept, students, and you have a very good book. Now you have thrown this projectile with the initial velocity u. So if you resolve this u in these two components, so of course this is adjacent. So adjacent side, you know that open Adam, open Hari Adam, and sine cos tan. So adjacent side is hypotenuse cos theta. So this is this adjacent side to theta. So this is hypotenuse your u. So this is u cos theta. This is your ux, and what will be uy? Uy will be equals to, so this is opposite side. So opposite is equals to hypotenuse sine theta. So uy is equals to u sine theta. So uy keeps on changing, but ux remains constant. So now here, as this Vy equals to 0 at the top, so you have only one component, which is the horizontal component, and that is why V is equals to Vx here, and this remains constant u cos theta, because this velocity remains constant because ax is 0, yx is 0 because fx is 0. So this is constant in the horizontal direction. Now again it is going to hit, I told you that this angle will be theta. So you can draw this angle here also, you can draw this angle here also. And these are, you can see these are vertically opposite angles, so they are same. Now students, I told you that how to resolve the components in terms of unit vectors. So this was your initial velocity u. I want to resolve this into horizontal and vertical components because we know that horizontal component is constant. This is angle theta. So this is your this hypotenuse is u, this length is u, so this is u cos theta, and this length is this direction, vertical component, u sine theta. So this is the initial velocity. So if you write it as ui, need not to write it even initial velocity. So initial velocity u is equals to, so how can I write it, students? So this is a vector, so I need vector here on this side. So its component, how I'm going to write? This is u cos theta, this is the magnitude, this is the magnitude. What is the direction? Because this is vector. So direction is I cap. So in x direction, move 1 unit and you get the vector I cap. In y direction, move 1 unit, you get the vector j cap. So j cap and I cap, they are unit vectors. Their magnitude is 1 unit. I cap is in the direction of x-axis and j cap in the direction of y-axis. Because how we write a vector? We write a vector by writing its magnitude, multiplying it with the direction as unit vector. So in x direction, it is I cap. Now y direction. So u sine theta. In the y direction, we have unit vector. So this is the magnitude in y direction. And then multiplied with this. So student, this is your vector. Means initial velocity. This is how we write vector. So very important notation. Very, very, very important. Okay. You must understand this, very easy. Now, what is the final velocity? So final velocity, let us write it as v. So v is equals to, now you have this component here. This is same u, and this angle is theta. So again, resolving it into components. This is a diagonal, of course. Now this is a theta, so this side will be u cos theta. Of course, this horizontal component is constant, so this u cos theta remains u cos theta. And the vertical component, the same speed which it has gone up, same speed it will come down. So this is u sine theta. Now, the important thing is that depend if you will come like this, not on time, and you were also absent in the previous class also, beta, see, you will not be able to understand. You have to watch videos, and still if you want to understand, just be regular. Okay, be on time, be regular. Now the topic will really looks difficult, it will really looks difficult, but doesn't matter, the topic is not difficult. See, none of the subject is actually difficult. You have to be regular. You need to study it regularly, and it will be easier. Okay, so just be regular. Now, this v, how am I going to write? This is the means u cos theta is the magnitude of final velocity in the x direction. So multiplying it with I cap plus. Now, if this component in this direction is j cap, what about the component in negative y direction? So negative y direction is minus j cap, right? So upward it was plus j cap, and in the downward direction it will be minus j cap. So minus, so u sine theta minus j cap. Okay, so the direction. So how much is the change in this velocity, the final initial? So how much is the change? So change in velocity. So change is always final minus initial. So this is your initial velocity. You can write it as and this is a final velocity. So if you subtract these two, so this is a final velocity. So v minus u, what will you get? U cos theta I cap plus minus, sorry. So you can write minus here also. So u cos theta I cap minus u sin theta j cap minus u. So that's your u. So minus u cos theta I cap minus u sin theta j cap. So both these signs will be, this plus will change to minus this plus. So this will cancel out. And ultimately what you get? This is delta v is equals to minus 2u sin theta j cap. And if you're writing only the magnitude, so that will be 2u sin theta. Student, this is a very important concept. We have done it earlier also. What is the total change in momentum? What is the total change in momentum? So momentum is nothing but mass into mass is not going, mass is not changing. So momentum is changing means mass into change in velocity, and that is equals to, so 2 mu sin theta. So so 2 mu sin theta is the change in momentum. This is very important formula, students. This is most important formula. We have done it earlier also. I told you that the momentum is you know, do you remember this formula that we did when a ball is, this is the ball and this is the ball is hit on the ball, or okay, at 90-degree, or suppose let us take a simpler example. This ball is hitting the ground and then it is going back. This is an elastic collision, so hitting with v and going back with v. What is the change in momentum? This is mv, this is also mv. It's means what will the direction? So change in momentum will be final momentum. What is the final momentum? If you are taking upward action as positive, this downward will be negative. Or initial motion of the motion is downward, it's negative. So if you are taking this direction as negative, or sorry, this direction as positive, if you are taking the upward action, you need to take as a negative. Okay, so upward action is negative. So final momentum is minus mv because direction is upward, so minus mv. What is the initial momentum? Initial momentum is, so you are subtracting actually, so you will get the same sign. So that is minus 2 mv. Remember? So this is 2 m. So we have done this question earlier also, and I told you at that point of time is that the magnitude of change in velocity means this magnitude is doubled actually. So here you have got this special formula 2mu. So here the theta is how much was your theta? Your theta is your yes. So theta is your students. Where do we have this angle theta? Theta is the angle with the horizontal, right? In the above case also. So that's 90 degrees. So sine 90 is 1, and you get 2 mu. So that's the same formula. You can apply it anywhere. Like a ball is hitting the wall in this direction, then it is coming back here in this direction. So here also, if you resolve this component, so this component will be downward and means this component. So you are resolving this this initial velocity, so its component, this angle is theta, so this will be u cos theta in downward direction, and this will be u sine theta in this direction. And again this is the elastic position, so this is u. So what will this component? This is u sine theta, this angle is theta, and this is u cos theta. So here, what is the change? There's no change. Like here, there was no change in the x direction, but here you can see there is no change in the y direction. U cos theta, u cos theta. So this minus this will be, so their vertical components will cancel out. There's no change in momentum here, no change in velocity. That is why no change in velocity, momentum. But here, uh, it is these two components will be added up. So here also you'll get this change in velocity is 2u sine theta, and change in momentum will be 2mu sine theta. So here also, students, so this theta here is with the horizontal, here it was with the horizontal, and here this is with the this vertical. So but it is doubled here in this, so vectors in one direction cancel out and they just added up in another. Here y, no change along y axis. Okay, but along x axis, yes. So net change in momentum, here also the same formula, 2mu sine theta. So students, this is very important formula. Of course these things are quite new for you, and it looks difficult, so it's just obvious. So if you are finding these things difficult, yes, definitely, because we are not doing numericals based on them. Definitely we'll be doing numericals in the next classes, so you will find them very easy. Okay, so don't worry about it. Your job is to be regular and just rewrite the notes again. Okay, so we are going to do enough practice, and you will find the similarity in lot of concept in physics. So basically there are very limited tools that we use, and one of the things that we have seen, that how this this is doubled, and it's in the direction of the direction of this change in momentum is in the direction of the final velocity, remember? Okay, so if k naught is the initial kinetic energy, then the kinetic energy at the highest point will be what? So kinetic energy is equals to half mv square. So at highest point, of course this is your Vy is equals to 0 vertical. So you are left with only horizontal component. What is horizontal component? Horizontal component is V cos theta, right? So V cos theta whole square. So that will be equals to half mv square cos square theta. And what is half mv square? That is your kinetic energy in the beginning. So that's kinetic energy. So this is your, you can write it as means if this has k naught, so this is k naught cos theta square, cos square theta. So this is the kinetic energy that is written over here, k naught sine square this, sorry, cos square theta is the kinetic energy at the final point. So the initial kinetic energy multiplied by the square of the cos theta. So very important point. What is the time to reach the maximum height? We know this. Time to reach maximum height. You know this formula. This is very simple thing. So you have thrown a ball upwards and it has reaches the maximum height h. Okay. So students, this is what we have done earlier also, these three formula, time, height and range. Do you remember these three formulas? We have done earlier also. Yes.
Yes, sir.
Hmm. So here, if you want to find the time and height, so you have your formulas like uh, upward motion, you can take this direction as positive, so direction of motion we can take positive, so this upward is positive, so downward direction is minus g. So you want to find t, so at highest point you know that v is equals to 0. This is your u. So u is equals to v is equals to u plus at. So here v is 0 and u is plus u, that is of course in upward direction, so you can take it uy, and this minus g, so a is minus g into time of the flight is t. So this gt will come this side, so gt is equals to uy, and t is equals to uy by g. So this is the time to reach the maximum height. What is the total time of the flight? So there is a time to reach the maximum height, and total time of the flight is double of it. You have reached here and then you have come down. So the total time will be 2uy by g. So that's your formula, 2uy by g. Okay. So that's your formula. So now you want to find the formula for h. So for h, v square minus u square is equals to 2 into minus g into h. So v is 0, so this is uy square. So this negative negative will also cancel out, and h is equals to u square by 2g. So that's your second formula. And the third one, r is equals to, so you know the means s is equals to ut plus half at square. So in horizontal direction you have your ux into t, and this will be 0. So sx is your range, and the total time t of the flight, that is 2u into g. So ux into 2uy into g. So this is 2ux uy into g is your range. Okay. Now you can clearly see that this t and h, they depends on the vertical speed uy, because g is constant, 2 is constant. So t and h depends totally on initially vertical speed. And if the two projectiles thrown in different directions, like these directions are different, but they have equal time of the flight, so they are definitely their initial speeds, in vertical initial speeds are same. So if means if they have this t same, so it means uy will be same, so that their maximum height attained is also same. So if uy is same, maximum height attained is also same. So if uy is same, then t and h will be same. Okay. Or vice versa, if t and h is same, it means that they are depending on initial velocity. So if they are thrown in different direction, but time of the flight is same, then their initial speeds are same. So maximum height attained is also same. So if ha is equals to hb, so then uya is equals to uyv, and then ta will also be equal to t. Okay. So when two projectiles are thrown, this very important concept, all these concepts are very important. When two projectiles are thrown with equal speed at angle theta and 90 minus theta, then their ranges are equal. Student, this is important concept. Ranges are equal, but maximum height attained are different, and time of flight is also different. Okay. So let us, even we can prove this result also. So if we have the angles theta and 90 minus theta, so this is thrown at an angle theta, and this is thrown at an angle 90 minus theta. Okay, so students, one thing is common, that is they are thrown with equal speeds, so this u is same. So what will be this component, students? This is u cos theta, so u cos 90 minus theta, and this is u cos theta, and this component is u sine 90 minus theta, and this component will be u sine theta, right? What is u sine 90 minus theta? Is nothing but u cos theta, and u cos 90 minus theta is nothing but u sine theta. So their components are actually interchanged when the angle is theta and 90 minus theta. So their horizontal, so see here, this vertical component becomes horizontal and horizontal becomes vertical. So whenever you are finding r, so r is equals to ux uy 2ux uy by g. So g is constant, so ux become uy and uy becomes ux. So that is why in both the cases you will find that the range is 2u sine theta into u cos theta divided by g. And I told you that this is the formula u square, and this is 2u square, u square, and 2 sine theta cos theta, we can write it as a sine 2 theta by g. So ranges are same when the angle is, and when will be this range maximum? So this range will be maximum when this sine 2 theta is maximum, because u and g is constant. So when is sine 2 theta maximum? So maximum value of sine 2 theta. So when is sine 2 theta maximum? So sine 2 theta, sine value maximum is 1. So sine 2 theta is sine 1 is sine 90 degree. So 2 theta is equals to 90 degree and theta is equals to 45 degree. So it means the range is maximum when you throw a projectile at an angle 45 degree. And you can see that this t depends on only uy. So in this case, you will have uy as 2 sine theta, and here u cos theta. So t will be different in both the cases. And similarly, h is equals to uy square by 2g. So definitely uy is different. So here the height will also be different in case of theta and 90 minus theta. So time will be different because uy is different, and height will also be different, but range will be same because range is 2ux uy. So ux and uy are just interchange in these two cases. And this is the formula for another formula you have got for the range. So this is ux 2ux uy g, and second formula is u square sine 2 theta by g. Okay, so very important discussion we have done, students. So these concepts are new for you. You can watch the video again, okay, and make your notes properly with complete understanding. That's all for today, students. Thank you so much for being with me. See you tomorrow.
Thank you, sir.